Pada kesempatan kali ini, kami ingin sedikit membahas tentang potensial energi dan kinetik energi. Potensial energi berhubungan dengan posisi, sedangkan kinetik energi berhubungan dengan gerak. Potensial energi menggunakan rumus M kali G kali H, dengan M adalah massa dan H adalah tinggi. Sedangkan kinetik energi menggunakan setengah mv kuadrat, dengan M adalah massa dan V adalah kecepatan benda saat ia bergerak. Lalu, apa hubungan keduanya? Nah, lihat dan simak contoh berikut ini. Berikut adalah contoh penerapan energi potensial pada kehidupan sehari-hari. Nah, simak soal berikut ini. Energi potensial menggunakan rumus M kali G kali H, dengan M adalah massa, G adalah gravitasi, dan H adalah tinggi. Perhatikan gambar berikut ini. Diketahui bahwa orang ini memiliki berat 78 kg dengan berat dari 9,8 meter per second kuadrat, dan setelah dihitung, tinggi bangunan saat ia akan melompat adalah 32 meter. Setelah dihitung, didapatkan hasil 24.485,76 joule atau 2,4 kali 10 pangkat 4 joules energi. Dan ini akan terjadi jika orang ini melompat dari atas ke bawah. Sekarang kita masuk pada energi kinetik. Simak dan perhatikan ilustrasi berikut ini. Untuk pembahasan soal berikut, simak dan perhatikan baik-baik. Ini adalah versi saya menggunakan bahasa Inggris. Disimak ya.
This inclined plane is inclined above the horizontal at an angle of 19 degrees. Just for emphasis, frictionless. That means the coefficient of friction is 0. Mu is 0 in this case. Alright, so here we go. The first thing we're going to do is we're going to draw in our X and Y coordinate system. The X-axis we draw parallel to the inclined plane. The Y-axis we draw through the object and perpendicular to the X-axis. You can see I have X over here, and this is actually X positive. I know, you know, when we release this object, it's going to slide down the inclined plane to the left. It's not going to just sit there because there's no friction. That's another video. It's not going to move up because there's some other object that's pulling it over a pulley and a mass over here. That's a separate video. The object is going to go down to the left. It's going to accelerate. I said this is X positive because I like to have it accelerate in the positive direction. You could call this X negative. You would just get a negative acceleration, meaning it's accelerating in the negative direction. But let's keep things positive. Alright, that is our X and our Y coordinate system. Now, you know we're going to use Newton's second law. F equals ma, the sum of the forces is equal to the mass times the acceleration. We know the object is going to accelerate in the X direction, so therefore all we're going to do is we're going to sum up the forces in the X direction, and they're going to be equal to the mass times the acceleration in the X direction. That means we want to solve for the acceleration in the X direction, and the acceleration in the X direction is equal to the sum of the forces in the X direction divided by the mass of the object. Okay? We drew the coordinate system in, we got Newton's second law set up. We know what the mass is, 7.5 kilograms, therefore we need to find the forces so we can sum them up. We're going to draw in, step 2 I like to say, is draw in all of the forces that are acting on the object. You're on Earth. I'm on Earth. Well, hopefully you're on Earth. Well, maybe you're on Earth, but I'm on Earth, and therefore there is gravity, and I know that the gravitational force acts straight down, perpendicular to my page, so to speak, straight down, pointing towards the center of the Earth. It's not drawn along the y-axis. That is the gravitational force. That is the vector that represents the force due to gravity. There is one other force. That force is the normal force. It acts straight up, perpendicular. Okay, I shouldn't say straight up, because it doesn't act straight up. It acts perpendicular to the inclined plane along the y-axis like that. Okay? Those are the only two forces acting on the object. Gravity and the normal force. There's no push. There's no pull. There's no external forces. There's no friction. But you might be asking yourself, this object I know is accelerating down the inclined plane. Therefore, there must be some force causing it to accelerate and kind of, let's say, kind of like pulling it or pushing it down the inclined plane. And there, in fact, there is. But that force is the x component of this gravitational force. A part of gravity is pulling it down in this direction. Not all of it, because if all of it was acting down in this direction, then it would be accelerating at 9.8 meters per second. But only a portion of it. So we need to break this gravitational vector, this force, into its x and its y components. The y component acts like that along the y-axis. The x component acts like that along the x-axis. You can see this component is parallel to the x-axis, and it's this component that is causing this object to have an unbalanced force, causing it to accelerate down the inclined plane. Now, I'm going to show you how to calculate the y component and the x component of the gravitational force. You'll notice we have a right angle here. This is a right triangle. We know one of the sides of the right triangle. In fact, we know another angle because this angle of the inclined plane is 19 degrees. These are similar triangles, therefore this angle right here is also 19 degrees. So we can use our trig functions sine and cosine to determine the y and the x component. The y component is equal to the hypotenuse mg times the cosine of theta. This angle is theta, 19 degrees. This side is the adjacent side. Cosine is adjacent over hypotenuse. Then we solve for the adjacent side and we get that the y component is equal to the hypotenuse mg times the cosine of theta. Now this side, mgx, the x component is opposite the angle 19 degrees. Therefore, we're going to use the sine function. Sine is opposite over hypotenuse, so the x component is equal to the hypotenuse mg times the sine of theta. All right? Now, we're not going to use the y component, but I just thought I would show you how to do both of those. The adjacent side is always hypotenuse times cosine of theta. The opposite side is always hypotenuse times sine of theta. Now, I like to, just for my own visual representation, graphical representation, I often just like to move this vector up so I can see that it's actually acting on the object. Okay? It's a vector that has a magnitude and a direction. As long as I don't change its magnitude and as long as I don't change its direction, I can move it anywhere I want to. So I'm going to slide it right up there, and now you can see it is the only force that is acting on that object in the x direction. So now we can sum up the forces. Well, there is only one force. It's mgx, and mgx is equal to mg sine theta. That's it. There's only one force to sum up, so to speak. Then we have the mass. We divide by the mass. You will notice we have a mass on the top and a mass on the bottom. Those are the same masses. They cancel, and therefore the acceleration of the object is equal to the acceleration due to gravity times the sine of theta. You should notice that in that equation, for our acceleration, there is no mass. The acceleration is independent of the mass. It only depends on the angle. Okay, the steeper the angle, the greater the acceleration. No mass. Mass does not determine, and mass does not affect the acceleration. So now we can simply plug our answers, plug our numbers in. The acceleration is 9.8 meters. The acceleration is equal to 9.8 meters per second squared times the sine of theta. And if you do that, you get that the acceleration in the x direction is positive, it's plus 3.19 meters per second squared, not dependent upon the mass. Now, you'll notice we were given the mass, but even if you were not given the mass, you should know that now you could calculate the acceleration because the acceleration does not depend on the mass. If you had left the mass in and just plug your numbers in here, of course you get the same answer. If you had put 7.5 here and 7.5 here, of course you get the same answer. But you don't need the mass. And sometimes you'll get a problem like this and students will say, I can't do this problem because I don't have the mass. And I say, well, you can do the problem because you don't need the mass because the acceleration does not depend on the mass. Okay? So there you go. It's a few steps. I think if you follow that process, it's pretty straightforward. Thank you very much for watching. I hope you found that helpful. If you did, a thumbs up or a great comment in the comment section would be greatly appreciated. Okay?
Gimana?
Thanks for watching.
Paham? Alhamdulillah kalau paham. Nah, berikut adalah hubungan antara potensial energi dan kinetik energi dihubungkan dengan ilustrasi berikut ini. Ketika posisi benda pada bidang yang ada di atas, maka potensial energi lah yang berlaku padanya. Jadi ketika turun ke bawah, energi kinetik lah yang berlaku padanya. Dan terima kasih telah menonton.